At TP-Link, we explore every possibility to deliver the most stable and seamless connection for our users. For the past several months, we've been running Wi-Fi 8 tests in our lab, and today we're going to show you 3 key features.
Wi-Fi 8 is the next generation standard, but unlike all previous generations, it's not primarily focused on raising peak speeds higher.
Wi-Fi 7 already reached 46 gigabits per second maximum throughput. Wi-Fi 8 shifts the focus to something more useful in real-world conditions, ultra-high reliability, or UHR. We're comparing throughput between Wi-Fi 7 and Wi-Fi 8 using a Wi-Fi 7 router and a phone, and 2 Wi-Fi prototypes and a laptop.
Since Wi-Fi 8 consumer devices aren't commercially available yet, we're connecting 2 prototypes to each other, with one linked to a laptop, giving us real-time speed results on screen.
The first feature is an upgraded modulation encoding scheme, or MCS for short. It determines how your router and device negotiate their connection as conditions change.
Yeah, the further you get from the router, the weaker the signal. With Wi-Fi 7, that degradation tends to be abrupt. MCS in Wi-Fi 8 is designed to handle it more gradually. We're testing MCS by measuring how distance from the access points affects throughput. We'll compare Wi-Fi 7 and Wi-Fi 8 as the devices move progressively farther away.
Wi-Fi 8 is faster at distance.
Yeah, Wi-Fi 8 added new MCS levels above what Wi-Fi 7 supports. When signal strength drops as you move away, it steps down more gradually instead of falling off sharply. That gradual adjustment is what keeps speeds from dropping the moment you move away from the router.
A router manages multiple data streams simultaneously for uploads and downloads. Unequal modulation, or UEQM, is Wi-Fi 8's approach to handling uneven signal quality across those streams.
We're adjusting the antennas to simulate signal weakening so we can see how Wi-Fi 7 and Wi-Fi 8 handle the drop in signal differently.
Wi-Fi 8 allows each data stream to operate at the best speed it can handle independently, rather than forcing all speeds to slow down to match the weakest one.
When interference degrades one stream, the others keep running at full speed. That 17.5% gain isn't just a number. It's the difference between one weak signal dragging the whole connection down versus the router working around it. In a home with multiple mesh nodes, there are zones where the signals from 2 access points overlap. In those overlap zones, devices can struggle to decide which signal to use, and that confusion shows up as slower, less stable connections. That's where coordinated spatial reuse, or CoSR, can help.
We placed 2 access points in the lab, approximately 8 meters apart. The client devices were about 5 meters from their connected AP. We're measuring the performance in the overlapping signal zone where the 2 APs interfere with each other.
For Wi-Fi 7, the total throughput for 2 clients was 693 megabits. For Wi-Fi 8, throughput increased to 907 megabits, a 30.9% improvement.
CoSR allows access points to communicate with each other and automatically adjust their transmit power to reduce interference in these overlap zones.
That 30.9% improvement translates to steadier speeds, fewer dropouts, and smooth calls and video throughout the home, especially in those areas where coverage meets. New MCS, UEQM, CoSR, 3 tests, 1 consistent result. Wi-Fi 8 delivering measurably more stable performance in the conditions that people actually encounter every day.
Stay tuned to tplink.com as we continue testing and move toward the launch of our first Wi-Fi 8 routers.